who have achieved a composite score
on the Graduate Management Admissions Test, GMAT, in excess of 630. In particular, the admission director
they're claiming that it's 50%. They're claiming that it's 50%. We are claiming that it's 50%. Claiming this.
director believes that the proportion of students entering
top-rated programs which support composite GMAT scores entering top-rated programs with such composite GMAT scores is now 50%. To test this hypothesis, he has collected a random sample of MBA candidates entering his program in the fall of 2012. He believes that these students' GMAT scores are indicative of the scores earned by their peers in his program and in competitors' programs. The GMAT scores for these 125 individuals are given in the data set, data 2012 sheet PO2 11. So that's the first thing, is when you open this up, you're going to be on the 2002 data. Make sure to switch your tab over to the 2012 data. I can't count how many times I've done that in class where I forget to switch tabs. Okay. Test admission directors claim at the 5% significant level and report your finding. Does your conclusion change when the significant level is changed to 10%? The way that the solution manual did this was to go through and create an entire if statement that could be tested for each score to determine if it's greater than 630, and then to place a yes or no in the column. You can do that, or when we go to count over here, I'm going to show you a different way of getting that same number 72, and then you don't have to hassle with creating that extra variable. So the main thing was that the p hat, that is the given population proportion, is 0.5, and the alternative hypothesis was that the admissions director believes that it's not equal to 5%. And so our null, of course, is the opposite of that. It's that it is equal to 5%.
Well, it said that it is equal to point. What is that? It says he believes that the proportion is 50%. What? You've got to be kidding me. It says that. It says the admissions director believes that the proportion is 50%. He believes that it is 50%. How does this even work? Seriously? Come on.
Which again, using the equal sign and the non-equal sign, we have a two-tailed test instead of a one-tailed test that we had before. With proportions, unfortunately, there is no quick and easy data analysis tool pack that we can use to get it done for us, and there's no way to even trick Excel. So we have to go through and walk through the steps of actually doing a few calculations, but it's not incredibly hard. Okay. So the first thing is that the sample size is 125. Now, the textbook solution manual did this by counting the number in the sample, but we were also told in the problem that the 125 individuals, so I could have just typed in 125. Okay. So now I need to know, of that 125, how many were greater than the 630? And again, if you did do that creating of the dummy variable, or the yes/no variable greater than 630, it's actually called the dummy variable, then you would just need to count the number of yeses like they did in this file here. I think it's easier, rather than doing that first step, is to do count if, and then actually add in, you have to do if first. if, and your logic test, you're going to land on your GMAT score, and then comma, and then quote greater than 630, end quote. And then comma, and here you would normally write true or false. So then we're actually just going to do our COUNTIF. Oops, I spelled it right.
Yeah, V2 is
So we're going to
What is
count
630?
if,
count. If
maybe this isn't that much easier, and maybe I'm not able to do this nesting. All of a sudden, I'm questioning my nesting. No, it doesn't work that way. I would need to do 2 steps.
oh no. Why is the null hypothesis?
Well, whatever. That, if I actually had started with a blank sheet, I would have just been able to whip right through it, but it's just throwing me off.
Like, I don't
So
get this.
it's probably not a bad way to do this because it breaks it down. You're able to see exactly which students yes and no are
We're not
above.
trying to prove it's not
And then
0.5.
doing the COUNTIF is fairly simple. You're just counting the number. Yes. So bottom line is in the actual sample, 72 out of the 125
Yeah, but I want to know how to
were
do
yeses. So that is actually 57.6%. And again, that's just taking the 72 and dividing it by the 125. All right. The standard, and so that's the p hat, or the proportion, or excuse me, p naught that we're trying to prove is not equal to 0.5. So p sub o. And then the standard error for a proportion is the square root of the proportion times 1 minus the proportion divided by f2, or excuse me, divided by the sample size. So for in this case, the proportion is,
Oh gosh, man. 8, 0. H0 equals P mean proportion. Oh, great. Proportion. What? Dude. What? P underscore what? Proportion. Oh. You know what's funny? I bet number 9 was just like that. I bet number 9 was like you weren't supposed to do more than or less than or whatever. You're supposed to do a 2-tailed test. P0 is equal to 0.5. H A P0 is not there's no easy symbol for not equal to. Dang it. Gotta be kidding me. Really? Great, now I have to actually find the symbol. Gotta be kidding me. How do you find not equal to? Now that was funny. Not equal to 0.1. That was funny. P hat equals 0.5. N equal 125. Number more than 630. Ooh. 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 Number more than 630. No. So equals if why did the professor go into more detail about how to do that part? It would have been nice if dang it. More than 630. If this is more than, okay, you know what? Like, why did she go into more detail about that? She just skipped over it.
Had. So we're going to count if in doing that first step is to do count if, and then actually add in, sorry, you have to do if first. If, and your logic test, you're going to land on your GMAT score and then comma, and then quote greater than 630. Greater to that were greater than the 630. And again, if you did do that, creating
count if blank to blank. Wait, hold on a sec. No, I need the other one. Yes or no. I need the yes or no thingy.
So the first thing actually doing, if you
No, wait, did you click on it or no?
120, the number is 120. So now I need to know of that 125, how many were greater than the 630? And again, if you did do that creating of the dummy variable or the yes no variable greater than 630, it's actually called a dummy variable, that 120. Counting is 100 credit. So we have to go through for unfortunate test, of course, is that it's the alternative hypothesis was that the admissions director believes that it's not equal positive that in the equal sign that we have an easy use to get it done for us, and there's no way to even trick it, actually doing a few calculations, but it's not incredibly horrible. 5 never in the sample, but we 5 into. I need to know of that 125, how many were greater than the 630? And again, if you did do that creating the dummy variable or the yes no variable greater than 630.
Dude, oh, she had her cursor over it, didn't she? Oh, I got so lucky. I just randomly got to it. If that is more than 630, comma, quote, yes, comma, quote, no. Okay, so if it's more than 630, quote, yes, comma, quote, no. There. So we'll go with this, and we'll do this equals count if all this, comma,
I'm going to show you.
so the range, comma, yes, quote, yes, quote, yes, and so there. Oh, you've got to be kidding. How did this? Oh, wait. It's actually supposed to be this. There. Now it's 72. So, this is taking forever. Proportion more than 630 equals is equal to this divided by this. So, and standard error is so I wonder if I can remember this. So it's equal to this. Oh, I forgot already. You gotta be kidding me.
That is the given alternative hypothesis was that admissions. So now I need to logic test you're going to land on your GMAT score.
I don't know why she skipped that. Like, she basically just skipped over that part for no apparent reason.
Or yeses, so that is prove is not equal to 0.5, so P sub O. The proportion times.
Okay, so it's this multiplied by 1 minus this divided by the number. So that times 1 minus this divided by, that was funny. And We have standard error of 0.001954. Of course, it's the square root of the number. Square root. Square root. Square root. And now we have the right answer. And then the z-score is going to be
One minus F4, the standard error.
Z-score. We got the proportion minus p hat. It's this minus this divided by this. Wait, what? Wait, no, divided by this. It's this minus this. It's the proportion minus p hat minus divided by the standard error. So we got 1.719. So, and then we have p-value. P-value is going to be whoops. So we have 1. So wait, what? Wait, why do we have both a norm distribution and we also have a different way of doing it? Why do we have two different ways of doing it? We have two ways of getting the same answer. This was from April of 2021.
So once you get the standard error, then we can calculate the z-score. The z-score is equal to the proportion minus the p-hat, so PO minus p-hat, so 0.576 minus 0.5, and then you divide by the standard error of 0.44. So once you have the z-score, we use the norm.s.dis function. However, we're asking for the right-hand tail, and so we would start off with 1 minus norm dot s.
But why are we
This is the standard
calculating that one?
distribution. That's why it's got the dot s in there.
But why would we calculate one-tailed?
For that, then is your z-score. And then the fact that you're doing it cumulatively instead of 0, which would mean non-cumulative. And that will give you the one-tail p-value on the extreme end, extreme far right end, okay? And then to get a two-tail p-value, if you only have the one-tail p-value, you simply multiply your two-tail or your one-tail p-value by 2, and that gives you your two-tail p-value. All right. So we jump from 0.04, which would have been saying, hey, we reject the null, to being 0.08. So we fail to reject the null.
The reason we did one-tailed is because there's no direct test to do the two-tailed. One-tailed. 1 equals 1 minus norm dot s dot dis z-score comma 1 2 times 2. You just multiply it by 2. That's it.
All right. So we jump from 0.08.
8, 5, 5. Um, and can you please still explain to me why the heck we're saying the null hypothesis is that it's equal to 0.5?
Or which would have been saying, hey, we reject the null to being 0.08. So we fail to reject the null at the alpha of 0.05. But if you raise alpha to 0.1, then we do reject the null. Okay. So again, it would be concluding something like the director of admissions can be confident that that the proportion of students with GMAT scores greater than 630 is not equal to 0.5 at the 10% level. All right. Okay, so yeah, p-value or proportions, student proportions is a real drag. Probably not literally, but the bottom line is that I'm not going to have you do any tests for proportions on the exam. All right.
Ooh, 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 ooh.
So the next problem, number 15, right? Yeah. The managing partner or major consulting firm is trying to assess the effectiveness of their spent professionals. Before and after post-training support, the claim that 10 new employees working knowledge workers are qualified for 1%. So the main thing when you open up for trial is that they have the 40 employees and their before score, and then they have a second tab with the after score. One way or another, you need to take those before and after scores and get them on the same sheet. And again, changing their top heading to just score to before score and after score. And again, this is paired by the employee across all 40 employees. You have both before and after. So we use what's called a paired t-test. Okay, so opening up the data analysis tool bag, we go to this t-test paired two sample for means. So again, when we can use two sample paired tests when you have like this, a before and after on employees. Another example, if you're comparing home selling price and appraised value, those two variables would be paired by the particular home. Another one I've seen is where you're looking at salaries or some other value for husbands versus wife. One was how much they're willing to pay for an automobile. And they were paired by husband-wife couple. Okay. But the most common are men and all right.
It's for my permit.
I hope you know that was recorded.
Okay.
Sample paired test.
I need you to read this. It's for my permit.
I hope you know that was recorded.
Okay.
That was the voice of my 15-year-old son interrupting me, even though I asked him not to.
Oh, I think so.
Yes.
It's for my permit.
Paired test. All right. So if you selected
I want
this,
to see. I want to hear what he said.
paired test.
Oh my gosh, it's too loud.
I need you to read this. It's for my permit.
I hope you know that was recorded.
Okay.
That was the voice of my 15-year-old son interrupting me, even though I asked him not to.
Oh, I think so. Okay. Moving back into this. I'm sure any of you with kids can relate, right? Oops. Start over here. Variable 1, the before scores. Or I could have done the after scores. Doesn't really matter as long as you do one in one column and another column. And our hypothesized mean difference is 0. For labels, checked off needs to be checked off. We could throw it on a new tab, or we could put it somewhere on this worksheet. I'm just going to say here and click on OK. This is the output that you would receive. And to show you here on this, as you can see, the main thing is we need to identify whether it's a one-tailed or two-tailed test. It's a one-tailed test because they felt that the after score was going to be higher than the before score, which after score is 84.25, the before score is 71.45. So you could write this two different ways. Since it's a paired test, we're actually taking the difference between the two values and doing a test to determine if those are significantly different.
Why did you do after and then before? This is before and after because I did this one first and this one second. Derp. 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 My goodness. The probability that t is less than t. Wait, did I do this right? Yeah. 7.49 and 2.26 e blah blah blah. Basically the um oh my goodness. What are we trying to do here? The difference is 0. Okay, we're gonna say d is less than or equal to 0. D equals after score minus t before score. So the difference is the null is that the before is going to be equal to or more than after. If after minus before is 0 or negative, then so d is less than or equal to 0. Alternative d is more than 0. D is less than or equal to 0. P is less than or equal to 0. D is more than 0. So 1%. The P value is extremely small, so this data support the claim that. Wait. Now that was funny. So the data support the claim that the scores increase after doing the training. Stop, 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 stop. That was funny. Number 17. That was funny. Before and after. Before and an after. Want to determine whether recent safety training workshops have to reduce the weekly number of reported safety violations. At the facility, the management team has randomly selected weekly safety violation reports. For each of 25 before and after, the data provided is it possible to conclude the workshops have effectively reduced the number of safety violations reported per week. It's the same problem, except instead of increasing it once, the decrease.
So in this case, the after to be greater is the thing one on the accumulate the parallel p. Okay, so scientific it's the 8.965. The 0.4 and almost the. So this one.
Okay, so they probably ran the same test. No, they didn't? Really? Why are we getting different numbers here? What are we doing? Oh, the variances? Number 17? What? We're just trying to see if... What? Why is it variance? We're not testing for variance. Are you kidding me? What's going on here? Oh, wait just a minute. Oh, what? What? No. No.
Yeah, you come up with violations and a tab that says before. And
why is equality of variance involved? This is the same type of question.
Violations dash pre, and I copied this data onto the after tab. Oops, I guess not. I copied both the post and the pre somewhere.
Why are we doing a variance test?
You can run them off 2 different pages, so that's must have been, but I would still recommend copying your first tab and pasting it onto the second, or something comparable, somehow getting them all onto the same page. Okay.
And 17. The managers of right? Yeah. Okay. The managers of a chemical manufacturing plant want to determine whether recent safety training workshops have reduced the weekly number of reported safety violations at the facility. The management team has randomly selected weekly safety violation reports for each of the 25 weeks prior to the safety training and 25 weeks after the safety training. The data are provided in this file. Given this evidence, is it possible to conclude that the safety workshops have been effective in reducing the number of safety violations reported per week? Report a p-value and interpret your findings for the management team. Okay, while this is saying there's some sort of training and there's pre-data and post-data, this is not paired because week 1 before is not the same exact week as week 1 after, right? They're obviously either at least 25 weeks apart, if not a full 50, or no, 20, we'd have to just be 25 because you go week one, and then week 25, and then you do your training, and then week 1 through week 25. Okay, so this is not a paired t-test. So as a result, before you even engage in the t-test, you have to determine, is there going to be equal variances or unequal variances in this data? And you could calculate the variances and look at them and determine if they're close enough or not. Or we could actually conduct a equal variances test. So opening up my data analysis tool pack and going up to F-test to sample for variances, I would get this window up, and I could select my violations post and my violations pre. And again, it wouldn't have mattered if you'd gone pre first or post second. I probably should have looked at what I have in my results already and made it the same. Checking off labels in the first row. And I put this on a new tab called equal variances. Called the equality of variance. So same thing, equal variances test. So this should be data. Our pre-violations 1.72, our post-violations 1.08. I did do the opposite of pre versus post.
But that's mean.
So the one great thing about the equal variances test is that the null and alternative hypothesis are always the same. The null is that the variances are equal, and the alternative is that the variances are not equal. So that's a two-tailed test, okay, which actually is inaccurate. Oh, the solution manuals don't get checked by the person or somebody that knows what's going on here. So the output for Excel always gives us only the p-value for a one-tailed test for variances. And to get a two-tailed test, you simply take and multiply 2 times your one-tailed p-value, okay? So 0.0035, which changes that. Which is still less than alpha of 0.05, so we would reject the null that the variances are equal and conclude that they are not equal, which is very apparent here, 1.12 versus 0.36. So not only did the number of violations go down, but the variance in the daily violations went down substantially as well. So no big deal. Instead of from our tab, when we go to get
Now that was funny. Oh.
From so no big deal. Instead of tab when we go to get our data analysis toolpack t-test, we simply choose this option where we're assuming unequal variances, go through the whole process again of inputting your data. It looks like range. Making sure.
This one first order. Before. After. I mean, which one is before and which one's after? Seriously, it doesn't even label them. Before and after. I mean, it's before. That was funny. That was. Derp. Derp. Derp.